Okay, we're now going on to questions where we're using a normal distribution, but we are given a probability. I call these backwards questions. Forward questions are when we're finding a probability. Backwards ones are when we're given the probability. And on backwards questions, I really strongly recommend that you start by giving yourself a choice of 4 pictures usually. So we've got 4 possible configurations. They're all normal distributions, of course. Okay, we could be working with a high positive z value or a low z value. And then in each case, we could be working with the probability to the left, or we could be working with the probability to the right. So if you've just got a single value to consider, it will be one of those 4 diagrams. I'm going to call them A, B, C, and D. Okay, and if you get the right diagram, it actually can be easier to draw all 4 and select the one we want. So we want the probability of z being less than a to be 0.9. So which could this be? Well, it could not be C or B because clearly that's not a probability of 0.9. And I want the probability of z being less than the value. Okay, so therefore I must be on that value or less. So it could be here. This value or less is a big probability. Can't be here. This would be the value or more. So this is picture A. So you draw all 4 pictures and then cross out the ones that don't apply. That's the most reliable way of doing it. So that's the picture we need. So we're now going to use the inverse normal table. And we have to be aware that the inverse normal that we're going to use assumes that you've got picture A or picture B. It always works with a probability to the left. Okay, although you won't be using the tables, just having a crafty look at page 24 of the formula book, which has the table on, can get you clear about what's going on. This is the diagram you get at the top of your page in the formula book. You don't need to use the tables, but it shows you that we're always dealing with a z value, and P is always the area to the left of that. So if you forget that, then this diagram might help you remember. So because in this case we have got a probability to the left, this is a correctly configured diagram, all I need to do is say what that area is, which is 0.9. Leave mu and sigma alone as always, and press equals, and it gives me a z value of 1.28. 2 decimal places is what's being expected here. So 1.28 is my z value. Okay, but of course I want to know, and of course z is all I need to know here because we're working with a z table. In actual exam questions you'll be wanting to use the standardization formula and turn it back into an x. So we're going to use the same idea for the other examples. So which picture is probability of z being greater than a equal to 0.8? Well, 0.8 is more than a half, so it's not picture C and it's not picture B. But this time I want to be greater than that value, so it can't be A because I'm shading to the wrong side of A, so therefore it must be picture D. So I'm going to be having to use picture D. This probability is 0.8, okay, which is the one I'm interested in. However, this is not the configuration that the normal distribution function on the calculator uses. It always works with the probability on the left. So I need my p-value to be this one here. Now the total probability is 1, so I need to do subtraction from 1. P is 1 minus 0.8 equals 0.2. That's the left-hand probability that my calculator knows how to deal with. So on my calculator, last time I was doing 0.9, this time I'm doing 0.2 for my area. Okay, press equals a couple of times, and that gives me a z value of minus 0.841. Well, I just need 2 decimal places, so that it gives me a z value of minus 0.84. And my diagram shows me that's sensible. Z is 0 in the middle, so this one here I'm expecting a negative answer. There's always that built-in check. So for the third one, which picture is it? Well, this probability is more than a half again. So again, it's not C, it's not B, because those are little probabilities. So it's A or D. Which side am I? I'm less than A, so I'm to the left of the cutoff. So I have picture A again. It's a probability of 0.75. Is that the right way round? Well, it's a probability to the left, so yes, that is the right way round. So I can go to my calculator. 0.75 is the area. Enter an area of 0.75. Press equals a couple of times, and then it gives me a z value of 0.674. So that's just 0.67, 0.67. So z equals 0.67. Which is all I need to do, and that is bigger than the middle, which is where z is 0, so that makes sense. And finally, for the last one, the probability of z being greater than a is 0.15. Well, this time this probability is less than a half, so it's not picture A and it's not picture D. Okay. Now, I want the probability of being greater than the cutoff value. Now, this has got the area to the left shaded, so that would be less than the value, so it's not B, it must be picture C I've got. So I draw picture C, and I show my probability of being greater than that value is 0.15, but my calculator doesn't want to work with the probability to the right. It wants to work with the big probability to the left. That's 1 minus 0.15 equals 0.85. So on my calculator, what kind of z am I expecting? I'm expecting a positive z, so that's the check when we get there. So enter my value. This time it's 0.85, 0.85 equals, and I get a value of 1.036, so that's 1.04. Okay, so is z equals 1.04 sensible? Yes, because z is 0 in the middle. This is clearly a positive one, so I'm pretty confident I've got that right. So that's how to get z values if you know a probability, but the key point is to draw this menu of 4 pictures and then make your choice. Don't try and draw the picture straight away, because you'll quite often get it wrong.